A problem was detected with the TrueDepth camera. Face ID has been disabled. And in today's video, we're going to repair this. We're going to use the new method using the i2C programmer and the new universal IC that allows you to repair the dot projector. So this supports iPhone 10 and 12 Pro Max, and this 12 Pro Max has a Face ID problem. So in today's video, we're going to walk through the whole process of the new method and what tools you need to do this repair. And if you need this repair done, let me know down below. I will link to my website so you can request a quote for mail-in service. So let's go ahead and get started with this tutorial. Make sure to check out DIYFixTool.com. They carry a wide selection of micro soldering tools for your repair shop, including the i2C programmer and the universal Face ID chip we'll be covering today. I will link the site down below. So the first thing we're going to do is, let me show you the error message. This is what it looks like. A problem was detected with TrueDepth camera, Face ID disabled. So anytime you have this exact message, you may not see this unless you're on like iOS 15 and newer. So if you're on older iOS, you might want to update and just to make sure you get that message. But if you do get this, then it's 99.99% chance your dot projector TrueDepth camera has failed. And the best way to verify that is using a programmer. So in today's video, we're going to cover the i2C programmer, and this is a 12 Pro Max dot projector here. So what you want to look for is the flex that goes to the dot projector, which is this sensor right here. So if you find that flex coming out of this one, you plug it into the programmer here, the 12 Pro Max. All right, I have this plugged in. Now, in previous videos, I used a different programmer. In this one, the button layout is a little different. There's left and right, and then the OK. So that matches left, right, and then the middle one is here. So it's a little weird because it doesn't line up with the display exactly. So we're gonna go to the, so when you boot it up and you have this board plugged in, it should go directly to the Face ID test. And then you pick this first one, click OK. And then we're gonna click the middle one, detect. And you can see there's a lot of red, a lot of abnormal, and this says please replace the cable. So we're going to use a new method. There's no cable replacement here. So this just confirmed that the dot projector has failed. Even if you don't do these repairs and you have one of these programmers, you can still at least test it to see that the dot projector is the cause of your problem. So now that we've confirmed that, I'm going to show you guys kind of what tools we need. So we need the i2C programmer. This is the latest one. This is the i6s. If you take out this battery cover here, you can install an iPhone 7 battery, I believe, and have it battery powered. So that way you don't have to just have it constantly powered via USB-C. One thing is this has to be powered via USB-C using just a regular 5-volt charger. If you use like a USB PD charger, it might not work. So just keep that in mind as well. Here's the new IC that we're going to be using. So we only need one IC for iPhone 10, 10s, 10s Max, 10R, 11, 11 Pro, 11 Pro Max, 12, 12 Pro, 12 Pro Max, 12 Mini. One IC can handle all those models. So if you're going to do a bunch of dot projector repairs, you can just stock up on this and cover all models. Previously, you had to have a unique flex for each model, which it just made an inventory nightmare to just have every single model in stock, which adds up. Also, this costs way less than the flexes from the previous method. So there's going to be some cost savings and some simplifying to this repair. We're going to need, another tool we need is a flat blade like this. We still need to do the alignment. Now, because we don't have to replace the flex, the alignment issue is a little bit easier to deal with because a lot of times the flex itself wasn't necessarily the right length, or it wasn't bent or curved the way the original one is. So it would sometimes kind of, because it's straight and flat, it'll push the sensor off to the side and then it causes alignment issues. Having to use the original does help with that, but you still need alignment tools. So I use these, the Kian Lee like magnetic alignment tools, which I'll show you how to use. Also, I highly recommend this jig here for working on the dot projector. It's heavy. It allows you to attach the dot projector itself there. You can attach the whole assembly here. and it does have reballing stencils as well. So if you need to reball something, it's there as well. So I've tried other ones. This is my favorite one because it's heavy and it doesn't move around. And then lastly is the glue. This is the MANT UV glue. So this makes it easier to deal with when you're gluing the sensor back onto the lens, which is the very last step. I do like that you hit it with the UV light and then it cures versus using like a super glue, which requires time. So there's that. And I think that's pretty much the main tools you'll need to purchase for these repairs. I'm assuming you already have soldering station, soldering irons and all that. All right, so let's get started with the actual process. This is a very important process to understand. Previous method, you do a read and then you get the new flex, plug it in and you write. In this case is different. So the way to navigate this programmer is anytime you're like in a page like this, you press and hold the OK button to go back one page. Press and hold it again, and then you go back. So the first thing when you buy this and you set this up, you want to go to settings. Just click right, click set, click OK. Then set your language. Most likely it's going to be in Chinese by default. And then push right, go to Wi-Fi settings, and then here you want to connect to your Wi-Fi. So this is going to be a pain because you have to just use the buttons to scroll and type in your password. But set this up because it's very important, which I'll cover here in the next step. Once you set up the Wi-Fi, you click OK and hold, and you go back one page. I never use any of the other settings, so just leave it as is. Maybe the sleep setting, so it doesn't go to sleep right away. Press and hold, OK. And then we're going to go back to face. Oops. Face. So this is the Face ID settings, click OK. In this step, we have the dot projector plugged in. We have to back up the data from the original sensor because we're gonna have to write it after the IC is installed onto the sensor again. So get your programmer. At the top, there's a USB port. You wanna plug in a USB to Lightning cable. Ironically, I'm using the JCP13 cable that it comes with, but it does work. So if you have that, you can use that for easier cable management. If you use a full length iPhone cable, then it's going to be kind of in the way. All right, you get your device that you're going to be doing the repair. So this dot projector belongs to this phone, and then you plug it in. It's a very important step, so make sure you pay attention. A lot of detail. So click trust, and you'll notice the charging symbols here. So that means it's connected. If you're not getting charging symbol, then something's not working. Maybe try another cable. I remember yesterday when I was using this, I had this plugged into USB-C for charging, and I think that was causing the phone not to be detected. So once I unplugged it, it worked. So I don't know. So if you're having that issue, just try it on battery by itself. All right, so now that you have this plugged in like this, you have the dot projector here. You want to go to backup. So you push right, you go to that page, click OK. And then give it a second to read. All right, so here you see it actually has detected the phone. So you see the model is 12 Pro Max, mode normal, etc., etc. And then you see here backup, no. Also, you see here Wi-Fi ready, part ready. So when it says part ready, it means the dot projector is plugged in. Wi-Fi ready, that means it's connected to my Wi-Fi here, my office, but the backup says no. So what you got to do is upload data. So this is where you click left, which is this button here, click left. And now it's going to go through a process to back it up. It's very important that you back it up, because if you don't back it up, you lose the data, and you do the process we're going to do after the soldering part, and you don't have the original data, data's gone forever. There's no way to recover it at this point. I think maybe with some other method, but it's a whole other story. So now you see this is backup yes. So what I would do here is, just to be 100% sure, unplug the phone, unplug the dot projector, That way you basically reset all this, right? There's nothing detected. So now plug it all back in. So you're essentially mimicking as if you went through the repair process. And there you go. So I unplugged everything, I plugged it back in, and it automatically scanned the device and it says download data successful. Also, you can click return and click it again, and it's still there. So if you're gonna do this, double, triple check this, because I'll be honest, it happened to me. Luckily, I did back it up using my other programmer to my PC, so I'm still able to repair it using the old method, because I was still experimenting and wasn't sure how this all works. Also, this can be used on your PC. So what you want to do is plug this into your computer using a USB-C cable. And then you want to have this tool installed. You get it from cputools.cn and then go to the download page. This is the i2C PC version of the software. It's pretty straightforward to use. It doesn't have too many functions. But essentially what you want to do is plug in this to the PC. It looks like it's actually upgrading it, which I didn't ask for. So that's it's another thing you might want to be aware of, but it did update it. Once you plug this into the PC, if you're having driver issues, here's the driver install option, but it should automatically go to this tab here, like the other programmers that they make. So it should automatically connect to this one, and then click connect. And there you go. It's a PC version. One of the benefits to this is you can back up. If you're not sure if this is backed up to the cloud like it did on the display itself, you can use this to test it. So click check dot matrix. You'll see it'll do the same test. You can see here is red. Red usually means not good. You could click reading encrypted data, and then now you could back up the data to a file to your PC, so that in case anything happens, you can have a backup here in PC. If you click local burn, that's where you can then, when you're all done with this process, you can use local burn to select that file and recover the data. Now, another thing is on a separate cable, plug in the phone. Make sure you trust it to the PC. All right, so I'm gonna disconnect, reconnect, and there you go. Here's the phone. It's plugged in to the PC by itself, and then the programmer is plugged into the PC by itself, and then the dot projector is still plugged into the programmer, like this. So I have the iPhone 12 Pro Max here, and then this is plugged into the PC. I don't have anything here, and then dot projector here. So now you can see this also, well, actually I did this earlier, so I already backed it up through here as well. So if you want to back up the data to the cloud, so to speak. By the way, this does require a login too, so you have to create one. It's pretty straightforward, just follow the instructions. But if you want to back it up here to the cloud, you want to select cloud backup when you have a phone detected here. If you don't have a phone detected here, it's not going to work. So there's many different ways to kind of handle this, but especially when you're doing your first few, you want to back up to your PC just in case, because there's no way to back it up to the device itself and have it saved permanently, like in the internal storage. It's only cloud backup. So if there's any like Wi-Fi is not working, or if you can't figure out how to connect Wi-Fi, you could just use the PC. But here's the cloud backup option. Once you're done with the repair and you come back at the end, here's the cloud burn. So this is kind of like the write from the cloud. So here's backed up. This is earpiece, which we're not doing. Break state, this is about unbinding, which is a whole different topic. But here's the first step you do. So whether it's within the device itself or with the PC, here's the steps. You want to back it up first. Read the data. So now that you have it backed up, let's do the actual repair. First thing you want to do is lock this down. So use these little handles to kind of hold that side. This side we have to keep it open. So you just peel this off, because we're going to apply heat here. By the way, If you've never soldered before, this is not a beginner type of repair, so don't recommend you just try this yourself. This is for repair technicians who already micro solder on a regular basis. Actually, this sticker, I can just leave it. Just my OCD, I guess, or whatever you call it. All right. All right, so first we got to clear the glue above, like in this area. Actually, just in this area here. So we're going to use, on my add-in hot air station, I'm going to use like this is 175. A really low temp. We just need it warm to soften the adhesive. I'm using the flat side of this blade, which actually I should probably clean. And always keep your hot air moving. Don't stay still. You can damage the front camera, which then is a whole other topic as well. Let me know down below in the comments if you want me to make a video on how to replace the front camera by itself without losing Face ID. I mean, it's pretty straightforward. Break open the bracket and put the camera in, but I know a lot of people have questions about it. So I don't know, maybe I'll just do it. I'll add it to my to-do list. So essentially, all under the shield, there's glue stuff. So try to clear that out. All right, so I think I got most of what I could on that side, so now rotate it. Now remember, we're gonna reuse this flex, so don't damage it. When doing the other previous method, I would be a lot more rougher because the original flex didn't matter, but in this case it does. So there's glue everywhere. All right, so maybe we don't need to clear all of it, but at least most of it. Now we gotta pop this sensor out of this metal bracket housing, and the trick to that is you gotta look at it from the side. So I actually use my little steel block here as a little stand. That way I can look down to the sensor at an angle. I'm gonna use, because remember there's a camera there, so you want to be careful not to overheat the camera next to it. So I'm gonna use 250 Celsius and 35% air. And you essentially want to get in between underneath this block here, and then down here is the lens. So want to push down. And essentially break the seal. All right, there it goes. And then once you do that, you push it down through, and that should be pretty much out. All right, so I got the dot projector flex out, and the lens is still in there. Just blow out any of the debris that might be left, and then leave that off. Essentially leave that there. Now next step, so this is where things change for this repair. So we got to get rid of this little MOSFET thing, this IC, and this cap. Clear out this whole thing. And now there's a piece of this here which we actually need to clear out a little bit as well. So essentially the new solution uses this new IC that replaces this whole area. So one thing to consider is don't damage these little wires here. You can see where they jump. So if you do damage one, you can run a jumper Now if you damage 1 out of 8 of these, then you don't. These have 2, so as long as there's 1 connection, it'll still work in my experience. So keep that in mind. I'm gonna use, what are we at? 250. Yeah, I'm gonna use that same 250 to clear out the underfill all around all these components. I'd recommend getting a brand new blade for this. That way you can clear out the most. Now this area in general is very tough, so you can be a little rougher than usual. It's not like a surface of a board. And always work where you're pushing your blade away from the sensor on the right. So you can see I'm only pushing left, because sometimes you're pushing and your tool slides. So always work away from the critical components, in this case being the sensor itself. Alright, so there, the cap is gone. You want to flatten this out if you can. Clear out the underfill around this IC. Oh, there goes that MOSFET. And then this chip, this black chip is the hardest one, so be patient. Don't raise the temperature too much, because one time I was, when I was still experimenting with all this, I raised the temperature too much and the flex itself came off the sensor, so that was a real pain to deal with. Now I'm trying to dig under this IC to clear out some of that underfill, but also help kind of loosen it. You could damage it, you don't need this chip anymore. And now keep in mind, my temperature might not be the same for you. My machine is not calibrated, so don't assume my 250 will work for you. Alright, here it comes. There it goes. So now that we got everything out, we need to clear the underfill that's on that area. So as you can see, it's very delicate work. So you can understand why we charge so much for this repair. It's years of experience to be able to work under these microscopic conditions. Alright, so I think I got most of it. Alright, now a little bit of flux. Now this whole area is hot anyway, so a little bit of flux just gets flooded everywhere. Then using just regular leaded 183 temp solder, like a Kester 6337, tin all the pads. Alright, since we did a quick kind of run through on that, the flux didn't burn too much, so we don't have to clean it for now. Now here's the IC. It is the FA02 IC. As you can see here, it supports iPhone 10 and 12 Pro Max and iPad Pros. So, and they're like $2 on IC. So that's way cheaper than some of the flex cables, which are like $8. 12 Pro Max can run up to like $10, $20. So something to keep in mind. So here's the ICs. So this is the tricky part because you don't want to lose them. But it's essentially a 2-layer IC. So there's like a flex kind of situation at the bottom and then an IC and a cap on top. So this is the tricky part, is in that you can potentially lose an IC in this process. So work under your microscope and be very careful. Okay, get the IC. and then put this one away. Luckily, these two pieces of plastic stick really well, so you're able to seal it back up, put it back in the baggie, and ready to go. All right, so essentially the little cap goes towards the sensor here, so it goes like this. Now keep in mind in that when you're cleaning underfill, you have to get all the corners here, because any little bit of, there's very little space for this. So that's the one downside to this design, is they designed it in a very tight fit. Also, like I said, this is a dual layer kind of setup. There's an IC on top of like a flex kind of situation. I am going to do a video on the JC method. So it's essentially the same thing, except the IC is slightly different, but the steps are identical. So even if you're watching this one, you'll know what to do for the other one, in that you follow the same steps. All right, so now I have the IC lined up, essentially all the way pushed to the left, and you don't need a reball, anything, just like that. So I'm going to use 330 Celsius and 25% air. This is essentially my reballing temp. I'm going to just flow this into place. So you can see it's already moving. There it goes. Now this is the tricky part. You can bump it or not. All right, I think it's soldered on. You know, I keep saying like I said, but I keep repeating myself because I've noticed some people don't pay attention. So I'm explaining every single step, and I still get people asking me something that's covered in detail in these videos. But here we go. So I'm just going to drop alcohol and blow it away. This does not damage the dot projector sensor in any way. And the only way to know if this worked is with the programmer. We stick it in the programmer and read or test it and then see. But you can see very little room for error here. So I guess this is a good thing in that you don't have to worry about the chip moving around. But the bad thing in that it kind of looks like it might not always have the right room. I don't know. But here we go. Here's the new solution. Also, don't ever stick any cotton swabs or anything that will clean this up, because you can easily damage those. But here's the new solution for the dot projector. So even though it looks dirty, I'm going to just leave it like that. Now the question to this is this faster than the other method? I still don't know. I mean, it's pretty much about the same time, but we'll see. I'll have to do a few more and get more efficient at the process. But yeah, so plug in just the flex to its spots, go to the test page, click OK. Oh, here we go. So here we have an error. I2C abnormal. Everything else is normal except the chip. So I'm going to maybe try to reflow it. You should get no errors in that process. So let's try this again. Now let me check the flex itself, make sure I didn't maybe float anything. And the flex looks fine. So this original flex is underfilled. So that's another thing to be careful, is if you use too much heat, you can potentially disconnect something within the flex, and then that's what's giving the error. Or it could be the IC is not installed right. So let's give this a look. So what I'm going to do is let me warm up the sensor first. And then I'm gonna add a little bit more flux and just use kind of the capillary action where it's like the liquid will just kind of suck itself into and under the sensor. Now I can try bumping the flex. I mean, I think that's installed. And then just wait a little bit. All right, I'm gonna have some alcohol and kind of clean that out. Let's try one more time. All right, I plugged it in. Detect. There you go. See, normal. So it's just bad soldering. So chip normal, all this normal. Down here, it's hard to see, but it says really bad thinking of blue background and blue text. Result normal. So dot projector is now fixed. Now we got to put this together into the metal bracket housing and then test it out. Get this out. We got to feed. Remember the sensor went in like this. Well, came out like this when it got to put it back in. Oh look, there's some glue there. Almost forgot. So usually what I do on these is using my, well, one, clear out the glue stuff on the top of the metal bracket. I think just that corner. Also, there's these three little tabs here. I like to pull them push them to the right, so they don't get in the way when I try to insert the sensor. So these don't have any function. I don't know if you guys can see those. Those three I push to the side. Essentially gives me more room to insert the sensor back in. So careful not to dirty the lens of the front camera. All right, so there I got a portion of it and just get it in there. All right, so now I'm going to use the alignment tool. Now this part sucks for the camera, for my microscope camera, because the bright metal tool messes with the auto exposure. So this part might be hard to see. But the goal is to fit this rectangle into this box here. Now you can just start off by centering this on there, and then this is magnetic, so once you line it up, you want to look in here, try to wiggle the cable so it gets in there, and now it's like kind of locked in. So if you look, depending on the model, you can see better. But this one you can't really see. But essentially the goal is to get that box within this jig here. And it's locked in, it's not going to move. And now this is the key to alignment. Well, one of the keys is make sure this box here is lined up. The sad part is you guys can't really see that. So this box here should line up with the lens. Alright, so you see here, well, from this angle it's hard to see, but actually missed the line. So just push it to the side, push this down as best you can, although it is kind of stuck based on the jig. And then on this bottom side, essentially this and this should be flush, meaning they're lined up, whereas on this side it's slightly offset. So you should see a little bit of purple here. You should always see a little bit of purple on this side, not on the other side. And then it should be straight. Right, so if you're unsure, you could always look at an original one that's not been messed with to kind of get a better idea. But you want to look for that and the straight alignment on the back here. So let's just assume that's good enough. We're going to use the UV glue, squeeze out just a little bit, and then with your fine tip tweezer, pick up a little bit, a little drop, and apply it here. Essentially, the goal is to get it on both the top and bottom side, and in between that crevice, and then hit it with the UV light. Give it about 5 to 10 seconds. You want to put thin layers of this UV glue, that way it cures right away and it doesn't have uncured stuff like within it. Because if you put too thick, then the outside will cure, but the inside will still be liquid, and then you don't have a good adhesive. Same for this side. Wow, you can't even see anything in there through the camera. I see it perfectly clear on my side. Alright, so I'm going to try to feed some adhesive here. I got some on the bracket too, but oh well. And so essentially adhesive, UV glue on both the top and bottom side, or the up and down side. This is more than enough to hold it in place. It won't come loose or anything. And assuming you didn't get glue on the actual jig, it should just come right out. Maybe I did get a little bit. All right. So I think this might be crooked. Well, let's test it. So just to be sure, you could test it one more time. That way you don't spin your wheels and wonder why it's not working. Normal. Also, when you do that test, you can look through a camera and see if the thing works. So let me turn on my microscope light. I'm going to run the test. Hold on. Yeah, so it's flashing a light through it, so it should be working. Now the important part is, does it work with the phone? So the next step is actually to program this now. So now that we have it all complete, we want to do the same thing as we did before. So put this back into cloud backup mode or whatever. So press and hold this. To go back one menu, go to backup. Actually, let me plug in the phone now, because it's going to request to scan it. It might ask to trust. Yep. Pretty much every time you plug it in, it's going to ask to trust. All right, so we're on the backup. It should say backup yes. Please, yeah, yes. All right, so because we have a backup here, we want to click write. So we've gone through the process of replacing those components with that IC. So now we got to program that IC with the data that is backed up to the cloud. So that's why you got to connect to Wi-Fi to do that. Or you could do it to the PC as well. You do the cloud burn. So in this case, we're going to click write, complete. I don't know why it says exit, no or yes. So I'm just going to click yes on the right. All right, so that technically should have programmed it. So now we can then assemble the phone and test it out. All right, so assuming the alignment is good, this should work. Now, I highly recommend you test with the screen fully seated. Even if you don't put the brackets, that doesn't really matter. It's just that the screen has to sit flat into the frame, because that can affect whether Face ID works. Or it might work with the screen out, but not when you snap it in. So let's give this a try. Yeah, there it goes. So it's working. Now, if you do this process and it is not detecting your face, my recommendation is, here, let me finish setting this up. So let's say you go like this to set it up and it's forever just kind of trying to focus and it never gets you. Try offsetting your face to like the left. Oh, it got me. But try setting up the Face ID so your face is not in the square, but you're slightly offset, and then see if it detects, kind of play with that. If it does, that means your bracket in there is misaligned. So for example, here's a different part. So when you're doing all these repairs, this thing can bend sometimes, like either this way or this way. So if this and the dot projector, these two IR cam and dot projector are not perfectly aligned to each other, then that's where you have issues with the alignment. If the dot projector was not glued into the lens properly, that can also cause issues. So I recommend, if you're having Face ID alignment issues, what I do is put the screen off to the side while the sensor is exposed, and then I'll use the Hedges 3D scanner app, and it should detect your face in a 3D model. If it doesn't, then that's when you can then kind of bend the bracket a little bit and then test it again. And then once it kind of picks up your face in 3D, snap the screen into the frame, and then test again, and kind of just mess with that. But essentially, your goal is to bend these out, maybe even twist a little bit, and just kind of mess with it. It's a real pain. I found the XR seems to be the most common for me to have alignment issues. Maybe it's just my jig, maybe, I'm too rough when I'm cleaning the glue and it warps the bracket, but I don't know. So I do want to say thank you to DIY Fix Tool for sending me this programmer and the chips. This is DIY Fix Tool offers a ton of micro soldering tools. Pretty much anything you can think of, they have it at great prices. So here they have a little blog about the solution I just covered, and it essentially walks the step-by-step process. Hopefully my video also is helpful for this repair. Check out the IC itself, which is FA02 chip, 10 pieces for $23.99. It's so much better than having to buy a flex for each model and then not knowing how many flexes to buy for each one. This time you could buy 10 ICs and it covers iPhone 10 to 12 Pro Max. And then you will need the i6S programmer, which if you can just search their site. I will link all this down below as well. Just the main unit is $41.99, plus you need the dot matrix board. So this is the one for the dot projector sensors. This is a full-fledged programmer, so this can do a lot of other functions as well, whether it's like the true tone, read and writes. It does the 12 series as well. Battery board. So if you're gonna do the BMS, battery thing, so that you don't get the notification. You can get a full set here as well for $125.99. It's a great programmer. It is slightly different than the other ones, but it pretty much does all the same functions. It's slightly different UI and the button layout, but yeah, it seems legit. I had no issues with all this so far, so I highly recommend it. DIYFixTool.com. So you may have noticed I'm wearing this sweater here. I can solder. It is an ugly Christmas sweater, so Christmas is coming up. We're already in early November, and make sure you guys order it now because it does take a little bit for the sweaters to be produced and shipped. So if you want an ugly Christmas sweater by Christmas time, get it now. Links down below. I've also linked to where to buy all these tools. DIY Fix Tool, you can search for it, but you could also click the links down below. So if you are enjoying these videos where I show you how to repair iPhones, all these different tools on motherboard repairs, make sure you guys smash the like button, subscribe to the channel, and check out this video right here where I do the dot projector using the JC method. So appreciate all you guys sticking around here to the end. Check out the links down below, and I'll see you in the next one.